Hello, Matrix Live. This is a very special Matrix Live because at Element, we had a hackathon called How Hard Can It Be? We spent 2 days and we did a whole bunch of stuff and we thought we might share it with you. And so that's basically going to be it. Everyone's going to be doing this super tight. We might do some slightly more involved ones after the fact. But for now, let's just dive in and get going. First up, we've got Benoit and we've got Florian, who are going to talk all about multi-account.
Okay, so I will demo the multi-account on ElementX Android. So first, I confess that I started this work a few months ago, just as a little poke. So I just asked to restore this old branch and introduce some cool design done by Aaron. Thanks, by the way. And so I also want to say that there will be no changes on the Rust SDK, which ElementX is using. So here you can see my emulator with an account which is already logged in, and I will log to another account. So we are going to the classical sign-in flow. Let's go. So it's using mass. So an account is already logged in there. And I enter the recovery key to verify the session. And that's it. I'm logged into another account, so Sing. So we now see that I have 2 accounts connected. I can do the thing again. There is no limit. And I can, of course, switch between the accounts. So this is the first account, and this is the second one. I also had time to implement the fast switch, which is done by swiping to the icon there. So I can switch between accounts very quickly. And
very cool.
Thank you. And another thing which had it done is the ability to select an account when sharing content from other apps. So for instance, here I'm on YouTube and I want to share a video. So if I select the ElementX app, I can now choose the account to share my content. So let's go to this one, and then I select the room and I can send. Let's cancel this. Also, we can see that we are on the Benoit X account. So I will send a message to the other account, and I should get a notification. So for the account which is not the current one, so let's wait a bit for the notification to come. Okay, I will change because I think I have disabled notification here. Let me do the opposite. Sorry. Okay, so I've switched to the other account. I sent a message to the first account. Okay, it's coming. So if I click on it, it will open the room with a new message. And then I can see that I have switched the account to go to the notification for the correct account. So it's a bit complex, but when you used to handle it, it's okay. And of course, I can sign out to the account. So I sign out to this account, and I will go to the last used account, and I can sign out again for this account. And then I'm going back to step 1. That's it.
Awesome. Very cool.
Thanks for watching, and I hand over to Florian, who will demo the same thing on Aurora.
Yes, thank you. So this is Aurora, a client built upon the Rust SDK, built I think some months ago during another hackathon. So here we have the user menu. When you click, you have a new button, add an account. So here I go through the normal way to log in Aurora. Let me take the time to sign in. So here I'm logging to another account. I switch automatically to the new one. If I click here, I can see I have my previous account. So I'm clicking in a switching account. I can send, for example, a message here. If I switch back to my other account, I can add my message, and here, if I click here, if I sign out, I'm back to my first account. And that's all in Aurora.
That's amazing, folks. I can't think of a more requested feature apart from, I mean, there's custom emoji and there's multi-account. So I think you hit the golden, the holy grail, golden something. Very good, very good. Right. Next up, we've got Half Shot. Half Shot, I'm not even going to explain the multiple hacks that you're about to demonstrate, so I'm just going to leave it to you.
So I've got 3 users here who will invite me to a room. No, I've got 3 users. Why am I got 2? So I've got a lovely co-worker. They've just joined the company. We share a private space, and Element's telling me this, which is quite useful to know. Also, they've recently created their account, so that's sort of like an informational. It tells you here in lovely lots of text, sort of explaining which headline is, which is quite useful. So you sort of know if you trust this person or not as a sort of a quick test. I've also got Bob. Bob's been here a while. He shares spaces, but I've also been active 182 days, at least as far as we can tell. So that's also good to know. We've also got Bad Actor. And this person has no shared rooms with me, and they've also been banned from rooms in the past, which is a good indication of whether or not I should be inviting damn good chaps to them. There's like numerous ways we could skin this cat, and there's more things I want to add to this, but as a quick way to do it, it's a very useful feature to have. So that's probably helpful to nearly everyone in this room, I suspect, who's had an invite in the past.
Very good, very good. Andy B. I thought Andy B was away. He's going to tell us about stitched order in the timeline. Are you there, Andy?
Hello. Yes, I am. Hello. Yeah, I am on holiday, but I'm briefly appearing just because I'm so excited about this. So if you've been anywhere near me recently, I'll probably have banged on to you about the order of messages in Matrix and how sometimes you see messages in different orders from other times, and that has knock-on effects and is also just a bad thing in itself. So rather than just bang on about it, I got chatting with Rich VDH and came up with some actual proposal about how we might improve it. So that is in the process of being developed at the moment, and there's this prototype MSC that we've been working on, which proposes essentially that you should always be able to see events in a consistent order. And because it's easy to say that and difficult to actually achieve that, we also have been working on a description of how servers might actually do this thing. So this is a big explanation of how a server might achieve that consistent order every time you look at events in a timeline. And so Rich VDH and I have been hacking over a couple of days to try and demonstrate that this algorithm can actually work in Synapse. So we got somewhere with that, but we didn't get to a fully working system. What we managed to do was to implement our algorithm and get the data into the database in Synapse and see it actually running. Unfortunately, we ran up against some of the something we weren't expecting or hadn't remembered about the way Synapse processes events. So because of the very sensible need that it has to process events one by one when it inserts events into the database, in order to authorize them and make sure that they're actually allowed to happen and they're all happening in the right order, Synapse processes those events individually, one by one, whereas to execute our algorithm effectively, we need to process events in a whole group that we received at a time. So we reached that point of like, there's this incompatibility with the way Synapse works. We have various proposals of how we would get past that. So we don't think it's a blocker. We think it's still definitely something that can happen. The two kind of possible ways of going about this is either to calculate your ordering before the events are actually persisted into the database, and then deal with the fact that they may clash with some other stuff that's happening later if it haven't been done in that very consistent one-by-one order. The other alternative is to process the batch of events after they've been persisted into the database and then sort of sort out their ordering after they're already stored. And in that case, you need to deal with the fact that sometimes some of your events don't yet have an ordering or may clash with another process that's doing the same thing at the same time. So we reckon another 2 really focused days would get us to something that works, probably with caveats about dealing with some of the corner cases. But we feel that we've the answer to the question, how hard can it be, is probably pretty hard, but we've got somewhere, and we think that this is still a viable proposal. So it's helping us to craft that MSC and this proposed algorithm to be more like battle ready. And if we get more prototyping time, we think we might be able to get a working demo. So no actual running things of Synapse working the way Synapse is supposed to work for you today, but progress on that road towards consistent order of messages in your rooms. That's it from us.
Very nice. Thank you. Thank you for choosing a real gnarly one as your Hackcode project. All right. When I saw it written down, I thought this was also a really gnarly one. Robin's going to talk to us about multi-SFU backends. Robin, how hard can it be?
Indeed. Hello. Am I audible?
Yes.
Okay, great. Yeah, so I'm on the VoIP team, and of course we've been building element call and matrix RTC. And now the issue, as soon as you start wanting to call people via these SFUs, these calling servers, is to decide, well, which calling server do we use? Now, since Matrix is a decentralized protocol, everybody may be on different home servers, which have their own infrastructure. So you can imagine there's like a number of users, each on different home servers. They each have their own calling servers. And how it works today is whoever starts the call just ends up deciding which server everybody is going to use for that call. So everybody converges on just this one right here. But that's really not ideal, because that's not like sharing the resources. It's not really making the most of our protocol design. So what we'd like is something like this picture, where every participant is just publishing their own media to their home server's own SFU, and then now every participant, to receive all the media for the call, just reaches out to every single server involved and retrieves the media. So that's what we have implemented in the past couple of days. I'm going to share just this screen over here, and well, just keep things short and sweet. I already fired up a call, but the deal is there are 2 different SFUs in use here. On the left, SFU A, on the right, SFU B, and we are, in fact, connecting to both of them from both of these element call sessions. So if I refresh this, then we can see, well, there's a bunch of connections here, but basically point is there's more WebRTC connections than usual. There are 8 here instead of the 4 that you would normally see with LiveKit. And I can go here and ask LiveKit, how many participants are there on each SFU? And so on the first one, we see there are actually 2 participants, because both users have, well, the remote user also has to join to receive the media, but only one of them is actually publishing any tracks. And then on the other, it's the other user that is publishing tracks. So yeah, this is a call that's split between 2 SFUs. And the nice thing about this, compared to the full mesh connection model that we originally started with when designing element call, is that this doesn't lose out on the nice benefits of SFUs being able to distribute the media for you. Clients still only have to upload their media once, so clients that have like really slow upload speeds still aren't going to suffer from this. It's the only thing that we're compromising on really is that you may have to like connect to further away SFUs and, well, just establish more connections to get all the media. So there might be some overhead. We're still going to evaluate how much that overhead actually matters. But yeah, that's the demo.
Super cool. Very nice.
I had a really quick question. For the channels that are connecting the SFUs together, is there any scope for them to subscribe to the right streams, or do they always subscribe to the kind of streams which they might need to display?
Whenever you connect to a remote SFU, you are going to look at the call membership state events of all the users on the call, and only the ones that say that are advertising a matrix room state that I'm publishing on this SFU, those are the only participants we're showing from that SFU. So yes, it's filtered down to exactly just what the matrix RTC source of truth says.
Okay, do you think there might be any scope to only subscribe to the ones which you're actually looking at? So say that the other person is broadcasting, but they're scrolled off the screen, and you're the only remote person. Do you reckon there might be scope to avoid needlessly sending it over?
Right. So LiveKit does already do this for us, where at least if a video is scrolled off screen, then we're not going to we're not going to be streaming the video. At least we will still have a WebSockets connection open and a WebRTC peer connection at the ready in case we need to start streaming something. The WebSockets is just to get the participant list, really. So we actually, know which tiles to show at all in the list. Yeah.
Cool. We're sure we'll talk about it more. Super, super cool. Okay. Really happy to see full mesh happen at last.
Yay. All right.
All right. Next up, Stefan, message bookmarks.
Hello. Yeah, message bookmarks. We realized that people would like to save messages for themselves to come back to later, or to reply later, or because they can't do it now. And we have pinned messages, but those are shared. You don't want to pin a message to the whole room to see. People have been marking rooms as unread at the moment, and then come back to it later and kind of find the message, which is not good, and we can do better than that. As it turns out, this was attempted before, around 2000, in an MSE called MSE 2437, stored tagged events and room account data, which saw implementations in the legacy apps and on Element Web. But because it was storing things in the room account data, it was a bit controversial, so it never actually made it past the feature flag, as far as I understand. So we set off to build it again, and build it the right way. Before I show you how this actually looks, this was very much a team effort. So thank you, Amsha, for raising the issue to begin with, Aaron for coming up with the designs, Guillaume for telling us all the backstory from back in 2000, Benji for taking care of the Rust SDK stuff, and Doug for providing moral support to me while I was building this. Cool. So I'm going to share my simulator, which you should see now. Is it big enough? Can you see it?
It looks good.
Yeah.
Yeah.
Cool. So you'll notice here at the top right, there's a new button, and when you click on it, these are your bookmarks. I went ahead and I bookmarked some things for myself. These are actual timeline items. This is our image for the room and this hackathon, and at the bottom here, there's even a voice message you can interact with and play. Right. So these are all from different rooms. This is one room. This is the matrix.org official account. This is Let Vanity Win from Element Web Desktop, whatever, it doesn't matter, right? If you long press it, you can deep link into the message. So now you don't need to mark your room as unread. You can just wait for the app to deep link into that actual message and highlight it for you so you can read it. Now you ask, how do you set a bookmark? Well, you go into a room, actually happens here, because why not, it's a demo, and you long press a message and you just bookmark it. When you do that, it sets a bookmark on it. It goes to your account data. It puts the event ID into the map of rooms to event IDs, and it just stores it for you. When you come back to your home screen, right, that bookmark will be up here at the top, and it's the first one because we also sort them by creation date. We figured the one you bookmark, the latest, is the one you're actually interested in reading, right? And you can, of course, go back and deep link you into it, and you can remove the bookmark, and it's all magically happening. Now, because this is on account data, right, it's synced, so you can see it on your other devices as well. But the cherry on top of all of it is that bookmarks would be way more useful if you set reminders on them as well. So what we do is whenever you create a bookmark, we also have a reminder date and a reminder timestamp on it. So what I did when I set this bookmark just now is that I sent myself a reminder for a local notification, which at some point might even have a proper title. But when it told me that 15 seconds later that hey, I said I wanted to be reminded of something. So when I click on it, well, that was the wrong one. But whatever. When I click on it, it takes me to the bookmark that I actually set. And this is again stored in your account data, so other clients might pick it up and show you those notifications as well. And that's bookmark. It's functional. It's there.
Boy, could I do with that? Very nice. Right. This next hack might be the most unexpected hack of the whole event. And Noah is going to present it, but I don't think that Noah, you were the one to do it. Is that right?
That is correct. We have an external contribution from Jason Little, who works at Famidly, but Famidly is not running this hackathon, so he was not able to work on it in work time. But yeah, I'm just going to show it off real quick. If I share my screen. Whoa, Inception. Yeah, so Jason went ahead and said, we're replacing all sorts of things in Python with Rust now. And something we spend a lot of CPU time on in Synapse is JSON, serializing and deserializing it. Can we just replace the heart of canonical JSON, which we use everywhere, with this library or JSON, which is JSON. So we did that and worked on it for a few hours. Seems to have got it working. Did not have much time to actually benchmark it, but we ran the test suite for Synapse in trial. And if I flip between these two here, you can see, this runs about several hundred tests. And it actually goes down about 30 seconds and maybe over a minute in some cases. So this is a huge, quick win for not much effort. So it's quite exciting, and none of us have got to do it. So props to Jason for just trying this out and getting it to work in a very short amount of time. External contribution.
All right. Well, thank you, Jason.
In terms of internal contributions, we have another one. So Jan, Quentin, and myself got together, and we wanted to make call recording and element call working. And let me demo it. I have an element call here. And if people go ahead and join this room, which I've just posted in element internal, you can pop in and then we can try recording the little call. I would recommend if people join, please put your camera on because it would be not as exciting. Hello. And as people filter in here, I'll go ahead and pull up the terminal. Oh my. Oh my. Okay, there's a lot of people. All right, just be careful of your microphones. All right, so Quentin went ahead and wrote a bunch of Rust code to go ahead and pull out the individual streams from an element call. So if I start this up now, you'll see that we have a new user that has joined called element call recorder. And they will just sit there and they will always not broadcast media. So it will just keep saying that. But you can see that another user has joined. It's not, you can clearly see recording is happening. And when you want, you can finish the recording. And what it's done is it's popped a whole bunch of streams into this output directory. We have video and audio streams separately. And this is for each user. Goodbye, everybody. And then you can just go ahead and use any sort of post-processing to stitch these together. We wrote a very simple script which just pulls out 4 of these and sticks them into a video using FFmpeg. So once that finishes, I will show it off. And I think I might still have old streams in here, so we'll see how this looks. But yeah, okay, yeah, there's one of my old streams. It doesn't actually delete the old ones. But you can see here that we have 4 people, and you could do whatever you want. Something that would be kind of nice, rather than just putting them into a grid, would be obviously to pull out the speaker information which the LiveKit client gives you, and then you can just show the person who's speaking. The other thing we really want to do is, well, we didn't have time, is just make a quick React app that allows you to pull in all the videos, and then you can click around and kind of like replay the call.
It's called Element Call.
Yeah, a similar UI to that, but maybe without all of the, microphone and camera buttons. But yes, the initial thought might be, why wouldn't you just open up a headless Chrome and record the screen, right? And we did also try this, and this is what Jan and I spent the first day on. And we sort of got it working, but unfortunately, when you try to stick a headless Chrome into Docker and then stick it into Kubernetes, audio recording from tabs just does not work. It is an unsolved problem. There were people asking about it literally yesterday that were unrelated to us. So we couldn't get it working, but maybe down the future, if instead you wanted to run this in a virtual, like a lightweight VM instead without Docker, you could do that. But we do have that code published internally. But we have a separate repo which breaks down the streams. And yeah, something we also thought would be cool would be to, since we actually have these audio tracks separately, you could very easily pipe that into Whisper and get a transcription. And then output those as subtitles. The other thing we wanted to do was, right now we're just dumping all of this video to disk. But what would be really nice is if we could actually stream that up to S3 and then have another process stream it down at the same time. And then you could do stuff like live transcription or, live stitching the video together so it's ready immediately as the call's done instead of having to wait for post-processing. Yeah, that's about it. So it works. We just need to stick it up somewhere. Oh, and the last bit is, you might have noticed from the call link, but there's no password. Encrypted video, we can't decrypt that currently just because the LiveKit client doesn't, we can do it, but it's just not out of the box. For some reason, they do have decrypted audio working out of the box. So we can pull audio from encrypted calls, but video will need to do some hacking around. There's different types of frame types you get with encrypted, whether it's a full frame or a delta frame. So we didn't bother with that, but it could probably be added with another day's worth of work. So yeah, that's it. Thank you very much.
Wow.
Very cool indeed. Very cool indeed.
All right, next up it's me. I wanted to solve the problem of, so we've got longer term schemes and plans to fix things like user status. But right now, if you are in a sizable account and you try and change your profile name, maybe to say you're on holiday or whatever you want to say, it doesn't really work. It times out. It sort of works for half the rooms or even less than that. And it's generally quite annoying. So what you'd really like is when you say update my display name, it comes back immediately. And then as far as you're concerned, it's happened basically instantly. That's what you would want. So this is what I tried to solve. And the hack, all it really does is it takes all of the items of work that normally the request sort of blocks on synchronously, and it does it in the background. So it returns almost immediately. It still takes just as long. But rather than work through the order of rooms just that sort of comes out of the database, probably, I guess, in sort of creation order, it takes a look at your read receipts. And so it says, if you have been interacting with this room, then you probably care about that one getting updated more than that DM that you haven't looked at for the last 3 years. So that's basically the thing. I'm going to do a very short demo of it, but basically it's me clicking a button and going, yeah, that was quick. So let's see if we can make that work. So what I've done is the actual act of upgrading the or changing your display name, I've actually put in a big delay. It takes about 10 seconds for each room to do that. And that's just to try and help with the demo. We've got a bunch of rooms here on your left-hand side. Test room 3 is the one I really care about. Look, there's all this talking in here. I'll just talk a little bit more. You don't need to be typing yourself. It can just be any read receipt. So if you're just following along or lurking in a room, as long as you're actually looking at that room, it will work. And now if I say, do you know what? It is time for a holiday. I'm going to go on holiday right away. So long, suckers. I'm on holiday. It returns straight away. You can see that that has happened right away in this room that I care about. The other rooms, it's just filtering through. Let's see if we can find one where it's actually done it. Yeah, there you go. This room has got it, and then the others will catch up shortly. All right. In real life, it doesn't take you 10 seconds to update a profile, but I just wanted to show that the ordering was there. This is something that particularly annoys me because it's the last thing I do before I go away, and it's the first thing I do when I come back. And so I just wanted to sort of try and scratch that particular itch. All right, that's me. Who's next? Some guy called Matthew?
Hello. Sorry that we are running into overtime, and I have about a 20-minute talk, which I will try to deliver in 1 minute. What could possibly go wrong? We should have called this "What Could Go Wrong" rather than "How Hard Can It Be?" Can you see shrinking, simplifying Synapse state storage with lots of problems?
Slides?
Yeah, I've got slides.
You changed, man.
I know, I'm behaving like a grown-up. So let me go quick. First of all, today when Synapse stores stuff, it does it in a DAG, not the room DAG, but when it stores state, it goes and builds up a directed acyclic graph of state groups. This takes up a hell of a lot of space. On matrix.org right now, it's about 9 terabytes. So we're talking tens of thousands of dollars a year of storage and backups. And if something goes wrong and you have to restore it from backup, it costs another 10,000. It's a nightmare. We've got about 30 billion state events, about 700 state groups, down from about 1.5 billion because we cleaned some of them up. It was the epicenter of the nightmare Postgres database corruption that we had last month. So for context, Matrix HQ alone is 150 gigabytes of state. So that's 1.2 billion state events, 400,000 state groups. The code surrounding this is mind-meltingly complicated, in my opinion, in terms of recursive queries everywhere, but many, many, many layers of caching that have been very carefully added over the years to make it go fast, despite the complexity. But I was wondering, is there a better way? So the idea actually came up was drawing this diagram for the kind of postmortem on the database corruption that we had. And as I was drawing these boxes, I thought, well, hang on a sec, why can't we just put them in a table? No, why can't we have a temporal table that tracks the lifetime of each event? That says that event 1 starts here and lasts forever, B starts at 2, lasts forever, I know H starts at 6 and gets replaced by I at 7, and then I lasts from 7 forever. And then to select the current state, you literally just select everything from the state table where the end is null or infinity. And if you want to get historical state, you say you want it where start is less than, say, 5 or greater than 5 or the end is null. And that's it. So no recursive queries, no DAG, just a plain old table. So how hard could it be? So went and experimented on Matrix HQ. As I said before, we're talking about 1 billion state row events. So after compressing it like this and putting it into a single table, ended up being 77 million rows, which is still a lot. So we're talking 8 gigabytes still, but still 6% of the original size. And it took about an hour to compress. So for context, we already have a compressor that goes and compresses the state groups, and running it on the same data set took us down to 30%, at least with the default options. But as I said, 8 gig is way too much. So we've got 3 million total unique state events in Matrix HQ ever. So you'd expect that to be millions of rows, not tens of millions. And the reason why, my friends, is temporal anomalies. That basically state resets or forks, or any kind of old events turning up, causing old state resolution, churns the whole table. So the way to compress it better is to reorder these temporal anomalies. So what I did was to calculate a min hash signature on every state set, which is basically a fingerprint, a bit like Shazam, of what is in that state at that point in time. And you end up with something that conceptually looks like this. You've got a nice smooth transition, and then there's a big jump because there's a state reset or somebody turns up with some old state. That goes on for a bit, and then it jumps back somewhere else. So we then split the table into these sections where they jump around. You then use LSH bands to look for splice points, so you can go and take out the misordered bit and put it in roughly the right place. Then you reorder, and you end up with something that looks a little bit more plausible. Now, if you're wondering why I'm talking about rainbows for this, it's because I literally did this using rainbows. So here is a real temporal state table, and you can see that it's all going well, and all I've done is to take the LSH 32-bit colors as web RGBA colors, put them in a terminal, and view them through. And in fact, I've got the real one hanging around here. You can see at the beginning, it starts off a bit crazy, and then as time goes on, it stabilizes more, and it goes nice and smooth. And this is after reordering. If I skip down to the bottom, it then goes a bit crazy at the end, because the actual reordering algorithm I used here ended up with a whole bunch of leftovers. It's actually one using ant colony optimization. So went through lots of reordering strategies, don't have time to talk about them all. One of the best ones was actually Brad first search through minimum spanning trees, and somebody please mute because you're making incredible noise. Then also experimented with doing like a optimal branching approach, experimented with Hilbert curves, which were completely the wrong tool for the job, then realized this is basically the traveling salesman problem, to find the optimal path through all these different state groups. And if you use the Lincoln heuristic, you end up getting it down to about 1.5% of the original size. So this was on a sample set, like a fifth of all of Matrix HQ, got it down to about 2 gigabytes for the whole thing. However, and the good news is that it's super fast. Queries take 20 mils rather than a second, so we've got about 60 times speed up. However, it did take 6 hours to run. Alternatively, you can do ant colony optimization, where you solve the problem by replicating or emulating ant pheromones in order to find the optimal path through the maze of how you reorder the sections. So lots more stuff that can be done there in terms of better ordering things. And we can also reduce this footprint by another 2 or 3x by interning strings, and probably get it down to a couple of 100 meg, I hope. It's all on GitHub there. However, what about Synapse? So Synapse really likes state groups and state deltas. And if you look for state group and state delta, you find there are 2,600 lines going on about state groups across the Python code in Synapse, and almost 1,000 going on about state deltas. So that's not great if your 24-hour hack project is to get rid of them. So why is this? It's because when we wrote Synapse originally, we kind of said, well, let's store state as a delta relative to whatever we already have hanging around. And then having chosen that design decision, we've really put on loads and loads of complexity for optimization for speed as opposed to disk space. So what happens if you want to rip it all out? Desperate times call for desperate measures. And I hate to say that I went to Claude Code and tried to one-shot it with this ridiculous prompt saying, hello, this is a problem to be solved, good luck. And about 20 minutes of pressing enter, lots and lots and lots, it came back saying, I have successfully implemented a temporal state system to replace Synapse's state groups. Here is what was accomplished, blah, 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 blah. And it all works perfectly. No internal server errors at all. The system progressed from crashing to matrix protocol errors. So well done, Claude. The core objective has been achieved, has been successfully replaced. Honestly, the repeated insistence that it had successfully completed its mission whilst having destroyed everything felt a little bit scary and a bit unhinged. So it was kind of useful because writing the prompt helped gather the thoughts. The patch that they came up with was actually useful to see what the real work would need to look like. It got me hooked because it kind of solved the blank page writer's block of feeling scared, frankly, about ripping this all out. And seeing the thing goes triggered my wanting to fix it because it's doing something so obviously wrong. You want to jump in and try to fix it. So I threw away everything it did and instead ripped it all out and did it by hand last night. And there is a PR on one of the private Synapse branches, which deletes 2,000 lines of code and adds 500. Not exactly optimized or well tested, but it does seem to work. And a very, very quick demo, if I go and run the thing here, so they're going, so if it is, and I'm going to set watching the database, and you can see we're looking there in its state table. And if I go and actually find an element somewhere, and I log into that server, no, really, I should be able to log into that. Nah, so I need to, weirdly enough, my crappy password is dead. No, what's going on there? No, It's going well. Well, let's see what happens. Logged in as Matthew 2, go to rooms, create a new room, call it test. Now, if you look here, then hopefully you will see a whole bunch of state events get created in a temporal table here. And it's literally like the one in the diagram. They start here, they end there. And if I go into here and I know add a topic to the room like that and hit save, then it gets added in here. If I change it again, hit save, you can see there the old state event gets killed. And if I change my nickname to Matthew, you can see I got a membership event. And if I leave the room, then I leave it too. So there you go. Now is a Synapse running with a temporal state table rather than a state group DAG. This is obviously very, very happy. The backend team to this. There's no way anywhere near production, but I'm going to keep hack on in future. So sorry, that was 10 minutes. Bye.
I don't know what to say, Matthew. I don't like saying nice things about you in public, so I'll keep quiet. But I did like the phrase "the end is null." That's not really the most important thing you just showed. All right, who wants to follow that? I think it's Keegan.
Hello. I'm going to share my screen, hopefully, and I also have slides. Do you see slides?
I do.
We do.
You do. Great. So basically, I'm working on policy server signatures, which is an MSC called 4284. The background here is that a policy server is a server, and it's used by Trust and Safety to basically protect rooms against spam on the public network. So the idea is that room admins can opt into using a policy server by sending a special state event into the room. The problem that I'm trying to solve here is that when a server creates an event, that event gets sent to all the other home servers. That's great. But then each individual home server is then going to go and ask the policy server if the event is spam or not, get told it's not spam, and that is really, really intensive on the policy server, and it would be really nice if we didn't have to do this. It's actually a little bit worse than that, though, because you may not be able to talk to the policy server, or maybe the policy server got updated, and therefore the spam check is non-deterministic, so as a result, you may not even agree on whether the same event is spam or not. So the solution here that I've been trying out is adding signatures to the event, basically. So first you send the event to the policy server adds a signature, and then that event gets sent over, and then all those servers can just check to see if the signature is correct, and if it is, it doesn't need to talk to the policy server at all. And the policy server is pretty happy about this. For future work would be to remove this kind of like check endpoint and just rely entirely on the signatures. If we did that, it means that we would be guaranteed that all servers would agree on whether an event is allowed or not allowed, and it allows us to express really complex policies. So things like, upon joining, you will not be able to get your event signed in the first 5 minutes after you joined a room, or without filling in the CAPTCHA, without doing something, which for the public network is really, really desirable. That's it. I will briefly show a terminal. So if I do this and then run this sanity check, this is going to create a room. It's going to join the policy server. It's going to send 3 events which doesn't use the signatures to kind of show you what's going on. It's going to send 3 events with the signatures, and then it's going to send spam, which is going to fail. So if I then go to here, so you can see each one of these thinking faces is the check endpoint being called. It's being called twice because there's 2 home servers. And that happens for each one of the 3 events without using the signatures. When we use the signatures, it's called the separate endpoint, the /sign endpoint is called, but you'll see that we don't ever call check at all. That's all that happens. It just scales in constant time as opposed to with the number of servers in the room. When you send an event that isn't, which is spam, the policy server will refuse to sign it. And of course, other servers may then optionally then try to go and call /check. That's just because at the moment it's a fallback. So if you can't, not everything's going to be using the signature method at the moment. And that's basically it.
Very nice. Thank you. Travis, rewiring ban buttons to use the moderation bot. Tell us about it.
Yeah, so on Trust and Safety, we spend a lot of our time, assuming I can find anything that isn't reasonably the correct tab here. So we spend a lot of our time, maintaining policy server and that sort of stuff, but then we also have these layered sets of protections. So we have a public room here. Some spam has made it through our imaginary policy server in this case. So to kind of show what we normally do to get rid of these users, we have to like click their avatar, find their user ID, copy that, go to this other room, type out a command that I'm going to desperately try to not typo here. It bans them, eventually it synchronizes, gets rid of them, it's all great. And it even tries to remove its messages as best it can. But that's a lot of context switching for us. There are some, obviously, like timeline issues if you're switching between rooms and that sort of stuff. So instead, what if you could just click ban from room, and instead of it using your personal account for that, it should hopefully in a second here, maybe, well, it did send the message, but possibly the bot on my end is just a little sad at the moment. It should go through and ban that user in all of the protected rooms, anonymizing who has actually done the ban. This is done through two MSCs, MSC 4333 and 4332. 4332 is a little bit more interesting because it actually adds the capability for bots to express the commands that they can offer. So in future, a client like Element could show all of those commands as / commands instead. So you don't have to guess the syntax or go to the room here and like try to remember the syntax for whatever this command is and that sort of stuff. But that's pretty much it. That's just a very small quality of life feature there, and it looks like it's picked up the other ban now, so it should go through and remove all of those messages and get that user banned.
Very good, very good. All right, we've got two left. Jorge, you're up.
Can you see now?
Yep.
Okay, so I'll demo an itch that I want to scratch for a very long time, and it has been asked by users for a very long time, which is basically being able to, on one side, if you want to react to a message, we can search for an emoji to do that. That's cool. And we also have support for the last recently used emojis, so we can reuse them again. And since I was already working on that, I also wanted to have some auto-completion here, so I can, for example, send something else from here in the message composer. And this is actually being shared. The recently used emojis are shared using the global account data. So if I now go into the same account in another device, I should have those same recently used emojis. So yeah, that was my demo, and it was super fast compared to the others, I think.
Seems good to have it though.
Yeah, thank you. And I think we've got the gist of what's going on there. Right. We're coming right to the end of things. Well done for sticking with us. Andrew, you're going to be talking about login for element call SPA. I think there's a super cool feature off the back of here that's not immediately clear from the title, but you talk us through it.
Yeah, sure. First, let me confirm that I am audible. I see a green outline on my tile. Thank you very much. I am going to find the right window to share because I have way too many. Just 1 second here. And as soon as I get that done, I will have the ability to talk about it. I swear I have over a dozen open. Okay, here. This is working. So typically when you start element call on the website version of it, as opposed to in-app calling, that's what we call the single page application or the SPA. If you don't want to use it as a guest and you want to sign in as your account, which would show you all of your active call rooms, you can log in, enter your username and your password, which is pretty standard. But now we have a fancy thing called the Matrix Authentication Service, which is more than just having to use a username and a password login for every individual client, such as Element Web, which is the same case here, username and password. But what if your home server implements the Matrix Authentication Service, or rather just OIDC login? I'll refresh these. I just swapped my home server to enable MAS. Now, Element Call is letting me sign in with MAS. And I have my account here. It lets me log in, as is standard going forward. I was able to log into Element Web. Don't worry about all this. Take my word for it. This does work. I'll just make this done so I know it's good. I am logged in. And now with Element Call, you can also do the same thing. Before, there was username and password here. But if the server doesn't support direct username and password logins and only supports authentication via MAS, now it is possible to do so with Element Call. And I will do this. And because I had already logged in to my MAS account from before, when I would log into Element Web, it doesn't have to ask me for my credentials again because I am using that same login session. Ignore the fact that these client names are a bit verbose here, but this is the right one. So this is just to be made a little bit nicer. But it says the same flow as before. I can continue. Also, don't worry about this. I'm pretty rusty with my React, so take my word for it. It does work. I will prove it by refreshing the page. And now what happens? I am able to start a call. And I hope my camera won't be taken up. And I am really able to start a call. This is a real call. And it is working with my MAS authentication. There are a few things that aren't done yet, but the gist of it works. So that's kind of nice. And that's that.
Yeah, very good, very good. Lots of uses for sort of conference roomy type stuff, stuff there. All right, Matrix Live. That's your lot. This is our bumper. How hard can it be session for you, including external participants as well. Have a great, I was going to say weekend, but you could be watching this whenever. See you then. Bye bye.